When we're looking at circuits, there's a few different arrangements that we have. And the first we're going to take a look at is what's known as circuits that are wired in what we call series. And I'll get to the definition of that in a second. But first, it's important that we understand what the different circuit elements are. And by circuit elements, I just very simply mean things like the battery, the wire, the resistors, or the things we're actually going to plug into the circuit, things like switches. And it's important to be able to draw a circuit schematic or a drawing. It would take a long time to draw like an artistic rendition of like a battery, a wire, the different resistors. So we have some simple shorthand symbols that we use for each of these. There's a tremendous number of them that you could use. We are going to limit it to essentially four or five. And I've listed right now the four that we're going to use in this class. The first would be the voltage source, and it's represented with a small dash by a longer dash, and then two lines traveling off in either direction. Now, the smaller dash represents the negative terminal, and the longer dash represents the positive. This could be a battery, it could be a wall outlet, it could be the power supplies that we've used in previous labs. But we're basically simulating the negative and the positive terminals of whatever is providing the voltage to that circuit. The voltage is what drives the current. Wires are quite simply just represented by lines. So up here, these are technically just wires that are coming off of that voltage source. A resistor, which is essentially anything that we plug in, it could be a light, a television, a cell phone, a lamp, a refrigerator. A resistor is anything that slows that current down and converts its energy into something else more useful, like light and sound for a television. It stores the charge in the battery in a cell phone, and so on and so forth. So all a resistor is just something that we plug into the circuit. The last thing we'll probably look at would be a switch. And this symbol is the same, but this shows an open switch in this case, which as you can see, there's a break in the circuit, so no current could travel through here. And then we have a closed switch, in which it basically just simulates like a wire. So you can think of like this as like a door. So an open door means that, or an open switch in this case, means that current can't travel through. But when you close that switch, like closing the door, it then maintains contact between these 2 points. So these are the four different types of elements that we use. And just to show you an example, this would be how we would represent some kind of circuit. So I have my voltage source over here, which is going to drive the current. I have three different resistors that are plugged in, which means, I don't know, a refrigerator, a television, and a microwave maybe. So three different devices that are going to use the current. I have a closed switch over here, so current can travel through. However, I currently have an open switch. So right now, no current will flow through this circuit. As soon as I close this switch, we will have the flow of electrons from the negative terminal to the positive terminal. As electrons will travel through these three different devices, I will get to power them, convert that energy into something more useful. So just realize that a circuit diagram is a simplified version using these elements, and I can show wiring for a whole house, a whole room, and it's a nice little shorthand version without having to draw every single thing, such as a refrigerator, television, so on. Nice simple way to draw a circuit. Now, the word series itself just means, much as in like a movie series where each one comes after the other. So you kind of need to watch the first movie to get the second one, and so on and so forth. Series just means each element is placed directly after one another. So in this case, this is a series circuit because I have one element placed after the other, placed after the other, placed after the other, and so on. Essentially, in a series circuit, current has only one pathway through the elements. So since they all come right after one another, assuming this switch was closed, of course, the current would have to pass through one element, then the other, then the next, then the next, then the next. There's no additional pathways. Series means you got one path to get through all of these elements. It's essentially just what series means. In terms of analyzing a series circuit, we'll look at the math a little bit later. Conceptually, there's three big concepts we need to understand. You're given a certain amount of voltage within a circuit, and that voltage drops every time you cross across a resistor or you pass through a resistor. The second thing is, since you only have one pathway, the current in each resistor is going to be the same because the current has no other option but to travel through each resistor. And the last one is that all the voltage you begin with must be spent, so to say, when traveling through a circuit. So while it drops across a resistor, by the time you travel through all the resistors, your voltage must be down to zero. It's like going on a shopping spree, but you have to spend all your money. As you pass through each resistor, you'll spend some of your voltage. When you get through the entire circuit, you have to get back with zero. So just to show you how these three are applied, I've drawn a small circuit here. It's a series circuit because I have these three resistors. I only have one pathway through. So to go to the first point, voltage drops across a resistor. So if I'm starting with 12 volts, in this example, I just made some numbers up now. We'll figure out how to calculate this later. But let's say it costs me, so to say, or I spend 3 volts getting through resistor 1. If I started with 12 and I have to spend 3 to get through resistor 1, then I only have 9 volts left to get through or to spend, so to say, on resistors 2 and 3. So across R1, that total voltage will drop. I'll go from 12 volts on this side to 9 volts over here in this example. Across R2, that voltage is going to have to drop again. I'm going to lose some of my voltage as I travel across a resistor. And again, it's based on what the resistance of R1 and R2 are, but based on those resistances, we can find out information such as how much voltage will be spent or how much voltage will drop. So just to rehash, I started with 12 volts. As I traveled across resistor 1, the voltage dropped by 3, and I then had 9. If in this example it costs me 6 volts, or the 6 volts is the drop as I travel across resistor 2, well, I started with 12, I lost 3, and then I lost 6. So over here, the remaining voltage I have left is only going to be 3, because 12 minus 3 is 9, and 9 minus 6 is 3. So as I'm going across these resistors, my voltage is dropping. All right, so if 3 volts was spent across R1 and 6 volts was spent across R2, well, that means I have 3 volts left to spend on resistor 3. And don't forget, I must spend all the voltage, or the voltage must drop to 0 by the end of the circuit. So that would suggest that that remaining 3 volts is what must be spent across resistor 3, because you can't have leftover voltage, so to say. And the last point is, as I said, with one pathway, the current must be the same. So if 3 amps of current leaves this voltage source, it's going to be 3 amps through R1, 3 amps through R2, and 3 amps through R3. Just as if this was a roadway and 3 cars left building A and wanted to travel to building B, there's only one pathway, so those 3 cars must pass through each toll booth or resistor in this case. All right, so just to look at a practice example, take a look, and I'm going to ask you to draw the following in your notebook. So I'd like you to draw a circuit diagram using the elements that we discussed in the beginning. So using these elements, draw a circuit diagram that meets the following criteria. You have a 120 volt power source, 2 100 ohm resistors, 2 50 ohm resistors, 1 30 ohm resistor, and a closed switch. Once you've drawn that, I'll also ask, if you look at this information and you assume the 100 ohm resistors have a voltage drop of 30 volts each, and each 50 ohm resistor causes a voltage drop of 20 volts, I'd like to know how much does the voltage drop across that final 30 ohm resistor. So take a second and draw a circuit diagram that incorporates these elements and see if you can figure out what the voltage drop across that last 30 ohm resistor would be. You can pause the video at this point, and when you're done, you can skip to the very end, and I'll have the solution to this so you can double check your work.